Good evening, matinee free വെബിനാറിലേക്ക് എല്ലാവർക്കും സ്വാഗതം. അതുപോലെ ശനിയാഴ്ച ദിവസം നമ്മൾ ടെക്നോളജി ടോപ്പിക്കുകൾ കൺസിഡർ ചെയ്യാറുണ്ട്. അപ്പോൾ ഇന്ന് ഇന്ത്യ സ്പേസ് എക്കണോമി ഓൺ ദ ലോഞ്ച് പാഡ് ഈ വിഷയം നമ്മൾ സംസാരിക്കുന്ന കണ്ണൻ സാറാണ്. 20ലധികം ക്ലാസ്സുകൾ സാറ് ടെക്നോളജി ബേസിസിൽ കൃത്യമായിട്ട് നമുക്ക് വേണ്ടി എടുത്തിട്ടുണ്ട്. അപ്പോൾ അതുകൊണ്ട് തന്നെ ഈ വിഷയങ്ങളൊക്കെ വളരെ റിസർച്ച് ഓറിയൻറ്റഡ് ആയിട്ട് നമുക്ക് ഫീൽ ചെയ്യും. പ്രത്യേകിച്ച് കുട്ടികൾക്കും അതുപോലെ എൻ്റർപ്രണേഴ്സ് എന്ന് പറയുന്ന തലത്തിൽ നിൽക്കുന്നവർക്കൊക്കെ വളരെ ക്രിയാത്മകമായിട്ടുള്ള അറിവുകളാണ് സാറിനോട് ലഭിക്കുന്നത്. നിങ്ങളെല്ലാവരെയും പ്രോഗ്രാമിലേക്ക് ക്ഷണിക്കുന്നു. അതോടൊപ്പം വൈസ് ചെയർമാൻ കണ്ണൻ സാറിനെയും. കണ്ണൻ സാർ, യു ആർ വെൽക്കം.
Okay. Thank you, Sabu. First of all, thanks to you for giving me another opportunity to talk on a very specific, very important topic today that has slowly assumed a significant role in our everyday life. Today, our life is, whether you like it or not, it is linked to some space activity. And as we go along, you will appreciate it better. Today's topic centers around space missions in India, which has happened in entirety during the life cycle of most of the people in the audience. Hari, me, and many others, Sri Kumar, Bina, we have all seen this right from the beginning of space missions in India. And we have had opportunities to visit Space Center, to see it at close quarters. And many of us who passed out from engineering college Trivandrum even aspired for a career in the Space Center after our engineering. Today, we are going to discuss these aspects and what makes space economy so important. I will take you through the complexity of this topic. Side by side, I will tell you how the ISRO also progressed its role and progress its missions. Side by side, I will explain that. So with this, I would like to give the presentation to you. Many people like me, as I told you, Hari, my brother, and many others in the audience will see that you will have some nostalgic memories about your earlier days when you had seen the Space Center. And I hope you like your journey through your memory lane during this talk. So I will upload my presentation now. Can you see it now?
It's coming, sir.
Full screen?
Not yet. Yes.
Not yet. Okay. Full screen. Okay. So India's space economy is what I'm going to talk about. And I've added another set of words. It's on the launch pad. So whatever you make out of it, when I say this title is, it's on the launch pad. It means it's ready to be launched or getting ready or not yet ready, whichever way you want to understand now. By the end of the discussion, I hope we will come to a common understanding of this. Okay, let's go further. I'm going to show you this cartoon of R.K. Lakshman. This cartoon was published in the newspaper in November 13 when India did the Mars mission. And when the Mars mission was done, there were only 3 other countries who had done before: USA, Russia, and China. and we are the fourth country to do it. And we did some special techniques by which we could reach Mars orbit using a less capacity vehicle and reach there. And this is a surprise to other countries. So this cartoon says it all. And the typical Indian farmer, typical agrarian economy of India is shown in that cartoon so well, and trying to enter the elite space club. We'll come back to this in case we want to talk more about this, but I will cover this Mars mission separately as we go along. So let's quickly understand what is space economy. It encompasses everything which happens in space, which will create value and benefits to humanity. So whether you send a spacecraft, you receive something from the satellite, or you are doing Earth imaging, whatever you are doing, it gives you some value. And there are some benefits to humanity if you analyze further. So all this activity which encompasses this is called space economy. It can be pertaining to exploring, researching, managing, utilizing. So all these functions are covered in space economy. It's a fairly new term to be used, definitely in India, but in Western media, it has been there for 4 or 5 years, not more than that. So space economy has got 3 identifiable segments. I will take the most simple out of that, the blue circle, spin-off to non-space application. You generate a new technology which is required for space, and then you find it can also be used for some commercial application. So that is one part of it. So leave out, that's very simple. What is remaining is upstream and downstream. How do you define this? Upstream is everything pertaining to making a satellite, making a launch vehicle, erecting it on this launch pad, launching it from the launch center, guiding it, remote control, injecting it into the orbit, everything which happens till the satellite functions and monitoring the satellite is upstream. And downstream is whatever is coming from the satellite back to Earth. It can be communication, it can be image, it can be analyzed data, whatever it is. So these are the 3 parts of space economy: upstream, downstream, and space-derived activities. Upstream requires a lot of infrastructure. You require a launch center, you require a launch control mission center, you require huge equipment to control the satellite, etc. But in the downstream sector, you're only receiving data, analyzing the data, and then making sense out of the data, what exactly it pertains. So it is more software oriented, while in the upstream, it is more hardware oriented. If you look at the breakdown. Okay. Now let's see the beginning of space missions in India. It had a beginning as TERLS in 1960s. Many of you may remember this acronym, TERLS. It is at Tumba Equatorial Rocket Launching Station. And the first of the rockets went to the launch pad by a cycle. This is not the full launch rocket. It's only the nose cone of it, but it was taken by a cycle. There's a very famous photograph, which ISRO very proudly talks about, that they were able to take their initial rocket component on a bicycle by one of his engineers. And TERLS was set up in a place called Tumba in Trivandrum. Initially, weather balloons were released from there for atmospheric data. Then subsequently, they launched sounding rockets. Initially, rockets were not made in India. They were imported from Russia as well as USA. But the first rocket was from USA, and it was launched in November 63. And it used to do atmospheric measurements, temperature, pressure, wind speed, etc., humidity, up to a height of 80 kilometers. So these rockets could go up to 80 kilometers height, and you could get the data from the sounding rocket. It used to be telemetrized, and it used to be received in the Earth station. Subsequently, we developed our own rockets, which was called Rohini, which was launched in 1967. It took about 4 years for us to make our own launch rockets, sounding rockets, and thereafter we started doing it ourselves. Now, ISRO was formed. When ISRO was formed in 1969, it was under the control of the central government. And then they realized you require separate departments to be formed. So they formed the Department of Space and an advisory body on what all technical missions they should do called Space Commission. These were formed in 1972, while ISRO was formed in 1969. And ISRO was brought under the DOS, that's Department of Space, in September 1972. So what did ISRO do in the first 30 years? That is from 69 to 1999. What did they do? So I'm going to just give a summary of it for you to understand what was the objective the government had tasked ISRO to carry out in the initial 3 decades. In the 30-year period, they focused on designing satellites, manufacturing the satellites, along with their rockets, which will take them high up into the space, essentially for communication, weather forecasting, and remote sensing of Earth. So let me spend a minute on it. Communication means you can send some data from here, and it will be received in the satellite, and from satellite it will get retransmitted. Whoever has got a receiver on the ground will be able to get the data and distribute it. This was used for school education. That means there was a program that satellites will transmit classes through, especially to rural schools. There'll be a centralized education package which will be transmitted up, and that will be received down below in the various schools in rural India, where they'll be able to see this lessons being shown on the TV screen. In fact, you would realize that TV also came to India in only 1980s, around 84, 85. So this is almost coinciding with that. So that is the initial uses of communication. Thereafter, communication went to so many things that you will see later. Weather forecasting. You wanted to know whether there'll be cloud formation, too much of rain, or cyclone is building up somewhere. We could do that from weather forecasting. They could also do remote sensing of Earth to seeing whether there is a afforestation program progressing well, or is there any intrusion into our border areas, because you could see the border area from satellite and see whether any movement is taking place. All those things were possible by the remote sensing technology. And we have slowly started doing it. Initially, the accuracies are not very good, but we have perfected it over a period of time. So these are the main 3 areas where ISRO was asked to focus upon by the government. So if you did a little bit of education program, communication, weather forecasting, there was a return to the general citizens of India, that they were getting back something from the satellite program. That is the story which you need to remember. So the contribution to the socio-economic sectors using the initial satellites, which are called INSAT satellites, and also the Earth observation called IRS satellite. These 2 satellites are different. INSAT is a communication satellite. He does not necessarily take photo imaging or infrared signature. He doesn't do that. But Earth observation satellites, which is remote sensing satellite, they use cameras, IR cameras as well as visual cameras, to see whether any data is giving details about what is the ground situation, which will be of use for defense, can be used for weather prediction, agriculture, and etc. So the contribution to India's economy, to the general public, was huge by this program. Also, during the first 30 years, ISRO progressed future projects like how to get navigation facility, like GPS. I'll talk more about it after 2-3 minutes. Mission to moon, mission to Mars, all those things also got discussed in ISRO in the first 30 years, how to do it, how will you progress this, etc. So let me show some photographs now. This is the first satellite which was made in India, called Aryabhatta. It was made in India in 1975, but we didn't have a vehicle to launch it. For any satellite, it has to be taken till the orbit by a rocket. And the rocket is called a vehicle because it can be controlled from ground. So it can be made to go left, right, whatever it is required to do. So that space vehicle required for Aryabhatta was not available in India. We are not ready. But so he took the satellite to Russia and launched from Russia in 1975. This is the first satellite. And you can see small window-like structures. They were all solar cells of that time because satellite requires power and the power will come from solar cells. So that it inside the satellite, you got communication equipment which need to receive and transmit. So they require power. So the power is to come from this solar cells. And I'm showing another photograph, 1999, the first 30 years. This became our satellite. You see the satellite, so much different from the other one. The side wings, like structure, they carry solar cells here. And this is a central satellite. And this was used for remote sensing, this particular satellite. And this was released in 1999. So the design of satellite took place in the 30 years. Both were designed in India, one 1969, one in 1999. Let's see some more photographs. This is the first launch of Aryabhatta from a Russian launch center called Kasputin Yar in 1975. Those days, these rockets were launched from this Russian Cosmos Center, which of course was much more advanced than what we were, or even almost America at the time, because the space had started becoming a hotbed of activities for both the US and USSR, then USSR at that time. So this is the first one. And this is a photograph of a rocket which we found in 1999, made in India. So this rocket, which launched an IRS satellite P4, the first satellite was weighing only 350 kgs. I'm talking of the satellite, which is carrying. The second one, satellite was 2.5 tons, 2,500 kgs we could send. The Indian-built satellite in the Indian launch station at Sriharikota. You will know Sriharikota, slightly north of Tamil Nadu in Andhra Pradesh. And from there, we could launch this very successfully. So in first 30 years, we went through a series of change in satellites and in launch vehicles. We made 3 launch vehicles during that time: SLV-3, ASLV, and PSLV. I will just, these are the pictures to give you a rough idea of the size. SLV-3 smallest, balance, the PSLV being the biggest. If you look at SLV-3, when I was doing my post-graduation project work in Tumba, SLV-3 was being integrated and getting ready for launch. All 4 stages were based on solid propellant. And I think one of my classmates was in that group, Bina. Now I remember Ajit Kumar was working there. Ajit was working in ISRO at that time in SLV-3 project. It could carry only 40 kilograms of payload, and it was launched in 1980. And if I remember right, the SLV-3 project director, just for benefit of youngsters, was Dr. Abdul Kalam. He was a project manager, not even director, project manager of SLV-3 program, by which he came to prominence in India on his space efforts. So SLV-3 was there for a few years. Then they started with augmented SLV. That means some more power so it can go farther, take a bigger weight. But some of this rocket did not work well. They had 3-4 launches, they failed, so they stopped it. Now comes, then they made a PSLV, Polar Space Launch Vehicle. It's a 320-ton rocket. It weighs 320 tons. It's got 4 stages. 2 are on solid propellant, 2 are on liquid propellant. Height is around 44 meters, the height of the entire rocket. It can carry 2.5 tons of payload. It was started in 1994. Now, I would like to spend a minute on what is PSLV, in case some of you have forgotten what is PSLV. Now, PSLV has become a workhorse. They have already done 62 launches from 1994 till 2 months back. They have launched. They have found it the most reliable space vehicle which they have used. Of course, they made some changes, etc. We'll speak about as we go along. But for those of you who want to know what does this word polar mean, that means the space rocket PSLV will take the satellite to the orbit, leave it there, and then fall off. And it may not come back to Earth. It will be somewhere in the space, going here and going around here, there, etc. But the satellite, which is in the orbit, will go around the Earth. Go around the Earth, and every round it will cross the North Pole and South Pole. So imagine Earth, it will be going a vertical movement around the Earth. North Pole, come down to South Pole, again North Pole. And this is what is polar satellite do. When you have a satellite moving like this around the poles, it will be able to see every portion, because the Earth is also turning. So if it keeps on going round and round like this, every portion of the Earth you will be able to see using the satellite. How much can you see? How clearly can you see? Will depend upon so many other factors. What is the height of the altitude? What is the accuracy of the camera? If it is for use for remote sensing, etc. But the more number, if the altitude is very high, then it takes more time to go around. If the altitude is less, then it will move faster because it requires circumference is less. Higher the altitude, circumference is more time it takes. So when it takes almost 24 hours for one round, it is called geosynchronous. So just remember this. Wherever you read something, if it is geosynchronous, means it takes 24 hours for one round, one rotation around the Earth. Whether it is exactly vertical or it is at an angle, etc., will depend upon the application. But here we are talking about North Pole and South Pole. If it goes to an altitude very high, and I'll tell you the value, 3,500 kilometers. I'm sorry, 34,500 kilometers. If it can go to 34,500 kilometers and make one circle, it'll come back to the same point only after 24 hours. And that is called geosynchronous satellite. Okay. Now let's go to ISR over the next 55 years. So in the first 30 years, what have we done? We have contributed immensely to education, weather forecasting, earth sensing, which is useful for defense, agriculture, fisheries, etc., etc. And we also made a reliable space vehicle which can take 2.5 tons of payload. Payload is the satellite, which has to be taken up and left there. Now, this is what we did in the first 30 years. Now, let's look at what ISRO did the next 25 years. ISRO's next 25 years, I'm just breaking down to 7 points, and then I will show the photographs of that. ISRO's focus areas in the 25 years is, first, they wanted to have a high power launch vehicle which can take a satellite heavier than 2.5 tons. I told you PSLV can take only 2.5 tons, but they wanted a launch vehicle which can take more than 2.5 tons and leave it in a geosynchronous orbit. As I told you, geosynchronous means it will be moving, rotating at the same speed as the Earth. That's why it's called geosynchronous. So it'll remain there looking at the same point. When the Earth is moving, it is also moving, and you will be able to keep looking at the same point. Now, in this case, I would like to give a slight example. Earlier, PSLV was North Pole to South Pole. Now we are going to talk about and around the same latitude, that is equator. So if you have a space satellite moving horizontally with respect to Earth around the equator, it's called geostationary. And if you have another satellite moving not on equator, but 5 degrees above equator or 10 degrees above equator, but still taking 24 hours, it is called geosynchronous. Actually, geostationary is one form of geosynchronous. When it's at equator, it's called geostationary. At any other latitude, it's called geosynchronous. So this was important. Then only you can watch the Earth, a particular point on Earth, all the time when you have your satellite and Earth moving together. Therefore, it was important that we have geosynchronous and geostationary satellites at different latitudes, which is important for communication. It is important for navigation. I'll come to navigation separately, weather forecasting, and our surveillance of our border areas. So this was the first aim of ISRO in the second period of 25 years. Second was we should be able to shoot down one satellite if you want from ground. Of course, ISRO doesn't have a method of shooting down. So they tied up a project with the DRDO saying send a missile from here and shoot out a satellite. I will talk about it more as we go along. Then provide navigation communication facility to citizens. Navigation is today using navigation GPS. GPS is based on US satellite. If US switches off the satellite, you will not have GPS in your phone. You will not have GPS in your car. If you want India to be independent, you should have an Indian version of GPS. I'll come to that later. But that is one of the aims of ISRO. Make an Indian equivalent of GPS. And communication facilities as required from urban India or rural India for telemedicine, telecommerce activities, etc. That is the third aim. Fourth aim, get private sector to participate in space missions. That has been a fourth aim. Pursue technological programs, Chandrayaan, Mangalyaan, Gaganyaan, Aditya mission, interdocking. We'll discuss briefly about this as we go along. Promote international cooperation for space programs. Get other countries to seek our help or take help from other countries for our programs. Improve our cooperation with other countries. And lastly, contribute to Indian GDP by space programs. That means you bring revenue to India through space programs. This is a good question. You actually spend money on space programs. How do you get money? We'll talk about it as we go along. Okay, so let us see some photos of this. This is a GSLV, which we have made. I should tell you that it started in 1990s, but it did not fructify till quite some time. And the initial version failed due to many reasons. One of them was the cryogenic engine, which we tried to make, did not succeed. Then we got some cryogenic engines from Russia as a full package and did some experimental trials to generate data. And simultaneously, we started making our own cryogenic engines. Now, why we did not get Russia to transfer the technology was that USA had opposed Russia giving this technology to India. And therefore, that is the time when USSR had just become Russia. So there was a little bit of the foreign diplomatic relations between amongst the countries. There was also in a flux. So Russia refused to give the transfer of technology. So we had to get some engines, ready engines from there, and then use it, fly it, do some experiment, and make our own engine thereafter, which we could do in Mark II in 2,500 kilos of payload it can carry. But that was not good enough for us. But India became the 6th country in the world to make cryo engines. Cryo engines are nothing but liquid. Both the oxidizer and the fuel are both a liquid, and they are kept at very cool stage, very, very cool temperature. And then they are allowed, when they are cooled, they are compressed, it becomes very small in volume. Therefore, the container required for them is also small. And therefore, the cryogenic engine will permit you to put more fuel in the same volume. And therefore, the space rocket does not become very bulky. So cryogenic engines have been made earlier by USA, Russia, France, Japan, China. We are the 6th country to make it. We have improved upon our earlier design to make Mark III. The photograph on the left is GSLV Mark III. It's a 51-meter high. It can take 4-ton payload into geosynchronous orbit. Earlier, I told you, we require something more than 2.5 tons. So this GSLV can take a satellite up to 4 tons. And that's what we wanted to put in the geosynchronous orbit. Geosynchronous orbit can also be geostationary orbit. Both are the same. At equator, it is geostationary. Any other latitude, it is geosynchronous. Now, Mark III, after it was developed, it has been used in Chandrayaan 2, it has been used in Chandrayaan 3, and it is going to be used in Gaganyaan and Navik, etc. So let us go forward and see how these applications went. But before that, one small photograph. This is how a DRDO rocket, when fired, went and hit a satellite. The satellite was at a height of 283 kilometers. They successfully engaged it. It was called Mission Shakti. With this, India became the 4th country in the world by which we could shoot down a satellite. Of course, before us, it was USA, China, and Russia. Now, I'm coming to Chandrayaan 3. Chandrayaan 3, as I told you, Chandrayaan 2 was a failure whose lander, Vikram, crashed. Many of you would have seen it live. I saw it live. Fortunately, I saw it live when it crashed on the moon. Now, we were very happy when Chandrayaan 3 was successful 4 years later. And where the lander, this is a lander, which opened the slide for the rover to come out. And the lander, Vikram, made a soft landing in Chandrayaan 3 in the south pole of moon and deployed the Pragyan, which is called the rover, which could go around this place. And it came down through this slope, through the slipway, and took this photograph. So this photograph I got from ISRO books. The photograph of Chandrayaan's Vikram taken by rover of Chandrayaan 3 is called Pragyan. Pragyan had taken this photograph. It was relayed back to ground station, and from there, it was put in this document of ISRO. This particular point has been named as Shiva Shakti by the government. Pragyan has collected a lot of data regarding source of water in the moon. All those data have been brought back to Earth, ISRO office, and it is being analyzed. Meanwhile, both lander and rover are on sleep mode. They have been switched off. They're lying there because they have finished all their tasks. They have collected all the data which they should, but they are sleep mode. They've been switched off for the time being. Now let us see Mangalyaan. This is the most fascinating mission I think they have taken. This was taken in 2013 by PSLV. As I told you earlier, PSLV rocket was only there at that point of time from Sriharikota. And it was injected into Mars 10 months later. It took 10 months to reach Mars using a PSLV rocket. Now, when PSLV was launched, it didn't have enough power. It didn't have enough power to gain momentum to enter Mars, because Mars, you have to break away from Earth gravity, and then you have to make sure that you're able to get into Mars orbit. So they use what is called a slingshot technique. They made the PSLV go around the Earth very fast, intentionally, and which picked up a lot of speed. And with that speed, they went out of Earth's gravitational force, and with that speed, they traveled to Mars for a long period of time, because there's nothing slowing them down in space. There's no retardation. There's no drag. So they continued at the same speed, and they were able to switch off the engine for some time. So they switched off the engine, and as they came close to Mars, they could fire the engine and build up some more power and get into the orbit of Mars. India became the first country to succeed in the first attempt. So many other countries have been there earlier. 3 other countries have been successfully there: Russia, USA, and European Union, not China. But they never succeeded in the first attempt. But India could do it in first attempt. And I think it's one of the outstanding missions of ISRO, Mangalyaan. And if you remember R.K. Lakshman's cartoon, it was on this, how they reached the Space Club, the Indian agrarian economy, which is known for its farming and agriculture. They're coming and knocking on the doors of Space Elite Club. This was based on this mission. And it completed all scientific tasks. It cost us only 450 crores, which is told to be 1/10 the price of what NASA expended for a similar mission. So we are very cost effective. And after 8 years, the satellite has been retired. Now, all the data has been collected. So it has gone into its own sleep mode. It'll be somewhere in the orbit somewhere, and it cannot die. So it'll be just going round and round, but it's not sending any more data. Right. So let's see the next one. This is about Gaganyaan. Now this Gaganyaan, I'm only showing the top 2 modules of the rocket, which I will assume these 2 modules are sitting on top of a huge launch vehicle rocket. Can you see a man standing here? This is just to show how big is these 2 modules. This is the crew module and the service module. In crew module, there is place for 3 crew. They will be staying inside this when they're launched into space, which can happen anytime next year. And the bottom module has got solar cells, and it's got some engines by which some last minute correction is required on the orbit, etc., can be controlled from here. Now, it is planned to send these 2 modules on a space rocket and put them at 400 kilometers above Earth. As I told you, there's a service module and a crew module for a crew of 3 days. They're planning to send this for a period of 7 days. That means our selected astronauts will be in space for 7 days, 7 to 8 days, right? 3 people will be going. They have selected 4. Out of that 4, 3 will be sent. And this crew module have the necessary life support. That means there'll be support, there'll be water, there'll be some sort of food, there'll be oxygen available, carbon dioxide exhaled will be removed. All the support systems will be available in the crew module, right? I can answer more questions on this during Q&A period. And the service module, as I told you, solar panel and liquid fuel engine for any correction. And when we send this modules to orbit, we'll be the 4th country to send a manned mission. So in the last half an hour, I've told you so many places we have fourth country, sixth country, fourth country, first country, etc. But we generally see that we have been in the first five most of the cases in whatever missions we undertook. So ISRO has really sort of a humble start in 1960s, has caught up with many other countries other than the leaders like Russia, USA, and China. And let's see how the Gaganyaan will take place. It will be launched from Sriharikota on a GSLV Mark III. That's the latest Mark III. It will go up. It will take 16 minutes to reach here. This is a low orbit, 400 kilometers. And these two modules which I showed you the previous slide, they'll be detached. So that will fly around the Earth few times. In those 6 to 7 days, it'll be in space. It'll go around. And when it finishes its experiment, the service module will be detached. That means which have the solar panels and engines, etc. They will be dumped into the sea. And the crew module will continue. And after some time, parachute will open. They will fall into the sea and they will be picked up by a ship. Now, ISRO has already done the trial for sending a crew module without crew up into space and dropping the crew module into the sea and a naval ship picking them up. That has already been completed. So that is over. So the splashdown will be somewhere in Bay of Bengal where a ship will be waiting. The exact location will be told to the ship. They'll wait there. So when this happens, sometime in 2025, they're saying, I have a feeling it will be 2026 when this mission will take place. It'll be a big step. We'll be the fourth country for having a space flight manned mission. Now we're coming to an important thing. I'm sure many of you already know this. In January 25, almost 35 days back or 40 days back, India was able to join two satellites together in space. It's called SPADEX docking experiment. They got two satellites to join by some locking system. Why do you have to do all this? This is required. Because tomorrow when you have a space station and you want to send something from Earth to the space station, the vehicle which is going from here will have a payload, and that payload should go and dock. It could be some crews going in, or it could be some items going in, or it could be some items to bring back, whatever you want to do. But they have to go and dock and become a part of the space station. So this is the experiment which they did, by which two satellites they launched. They were one behind the other. One was intentionally made to slow down, and one was made to do faster. So there's a gap. Then slowly they started the experiment by which the one which was lagging behind was asked to catch up and come very close, and then they docked. They attempted 2-3 times. Fourth time they succeeded. And now they're at the moment they're docked and they're flying in space. In March, around middle of March, they will undock now. They'll unlock, and then you will find that satellites will be again separate. It's a very interesting experiment which India has done. And when this completes, we will come to hear that India's fourth country or fifth country to have done this experiment successfully in space. Now I come to the last part of the application, the next 25 years. This is Indian GPS. Pay a little more attention. This is a little critical and a sad story as well. So I kept it for the last application. Can you see this photo? There are 7 satellites. We require 7 satellites at geosynchronous altitude, that is 36,500 kilometers above Earth, to cover India and some part of sea around India. 7 satellites. 3 should be geostationary, that means they are flying around equator, and 4 geosynchronous at a different angle, at a different latitude. It so happens it is around 40 or 42 degrees latitude. So when we have designed a system with this, and it's comparable to GPS, GLONASS of Russia, Beidou of China, QZSS of Japan, and Galileo of the European Union. These are the other countries or other agencies which have GPS equivalent. So we started this. We require 7 satellites. We launched 11 satellites during 2013 to 24. First 9 by PSLV, since we had to go to geosynchronous altitude. PSLV did not have enough energy to take to that height of 36,500. So they fitted some extra rocket outside PSLV's body and took PSLV as the main center one. That's why it's called PSLV XL. And they took it up. And the last 2 was by GSLV. But then GSLV became ready. Since GSLV was not ready due to the problems in the cryo engine, they modified PSLV with some extra rockets strapped onto it, and they could send the satellites to the correct altitude. But the satellites did not work well. 7 satellites failed out of the 11. Out of that 11, 9 by PSLV XL and 2 by GSLV. The 2 GSLV worked, but out of 9, only 2 survived, 7 failed. And there was a problem in the clock. Why do I say clock? In GPS, the most important aspect is the time reference. What is the time reference of your location here? How many minutes to go there? What is the traffic from half an hour from now? All these things you see on the GPS map. But the most important aspect is the time. And then comes latitude, longitude. So the clock has to be extremely accurate, and it has to be the same on all satellites. Identical time. And that can be obtained only by an atomic clock. In this case, rubidium clock. The rubidium clock we were not able to make in India initially. We tried to get it from abroad. Israel gave us some rubidium clocks. Based on that, we made rubidium clocks in India. Some clocks were sent in space through this satellites. They didn't work. Now we are perfect in the design. Indian rubidium clocks are there in the GSLV. But what had happened is that out of the 11 satellites we launched, we are surviving with only 4. And 4 is not enough for GPS. For a global positioning system, 4 is not enough for us. We require 7 minimum. So we require 3 more. Now, so we launched the 12th in January 25, 2 months back. And you may have read in the paper, it could not get into the geosynchronous orbit because some valve which is supposed to fire the engine didn't work. So it got stuck in the transfer orbit. Transfer orbit is a place where it initially goes and it is released. So it will be there in that orbit. Then slowly, it will go to its final orbit called the geosynchronous orbit, corresponding to whichever latitude it is supposed to go. Now, this particular 12th satellite, which we launched in Jan 25, did not reach the synchronous orbit. So it's of no use for GPS. It has to be in the correct position. So we have a problem. NAVIC, navigation through Indian constellation, requires 3 more satellites to go. Only 4 are there. 5th one is not reached. So we require 3 more to go. So I don't see the Indian citizen getting NAVIC, that is the Indian GPS equivalent, before 2030. Because it has to go there, then the GPS has to be tried out on Android phone and iPhone, which is manufactured in India. You may be aware the iPhones, etc., have been modified with an additional antenna called the L5 antenna so that it can receive NAVIC signal So a lot of preparatory work has been done by ISRO and Department of Electronics. But the sad story is this has not been a successful project for ISRO. ISRO is going through some time during NAVIC launch and NAVIC program. Okay, so let us see what is the next. Next point, which was important, was private sector participation. It was one of the important aspects of the. So ISRO formed two other organizations in 2020. It started in 2020 called InSpace and NSIL. InSpace is Indian National Space Promotion Authorization Center. The other is New Space India Limited. Very simple. InSpace is an autonomous agency and NSIL is a PSU. Now, InSpace is a single window. If you want to do something for space as a private industry, you go to InSpace and say, I can make this electronics for you. I can make this chemical for you. I can make this electronic equipment for you. I can make this in aluminum for the satellite body, whatever it is. Or I can supply solar film panel. So you want to do anything for as a private industry, go to InSpace. That is the single window agency for licensing, regulation, safety, international norms, and hand-holding and testing by ISRO, design reviews, etc. All this InSpace does. Single point. And only if InSpace recommends, you will get an opportunity to contribute, to participate in the space mission in India. While NSIL is a PSU. What he does is, when ISRO is getting ready with a satellite, he will buy the satellite. Who will buy? NSIL will buy the satellite. He says, I am buying the satellite for XXX crores. And when it is placed in orbit, he will say this satellite is available for use for other commercial purposes. So if you're having DTH in your house, direct to home, satellite TV, if you're having, it's coming from a satellite. Tata Sky is actually bought transponders in the satellite to give you TV in your house. It is coming from a satellite. So NSIL will say, I got a satellite and so many transponders are available. Whoever can quote for it, come and buy from me. So he enters into a commercial this thing and he gives away some transponders to Tata Sky, something to some other company, maybe for Geo or some other Airtel. Whoever is wanting to buy from the satellite TV, he will give it. And he will also give it for people who want to do research in Earth observation, right? Let us say Ministry of Forest wants to see how afforestation program is taking place in India. How many trees have been planted? Is it growing? Is the forest getting denuded? You want to monitor all this, you require satellite picture. So they will say, we will buy the data from you, we'll analyze it ourselves. So the ministry buys the data from them, or some other private company will buy. You see a lot of private companies giving weather forecasts now. How are they doing it? They're buying data from NSIL. They buy transponders from NSIL and take the data, and then they have got experts who will analyze the data and say, cyclone is moving like this, it is at so and so speed, etc. So the commercial part of ISRO's data sent to Earth by once ISRO made satellite, but now owned by NSIL. The data is being sold by NSIL to private companies or to public offices or to the defense sector and saying you use it for your purposes and see how you can move your work based on this data. So this is a change which has come in 2020 and it has started seeing good results. It has not only brought up many startups As we talk about it, we'll come to know. So this is the new entrant to the organization of ISRO. Very important extension of ISRO. There was a earlier one called Antrix Consultancy Limited, ISRO's commercial arm. That is still there, but it's doing only consultancy. But their work has been taken over by these PSUs and in SpaceX. So let us see. ISRO has got about 46 centers all over India, as shown in the map. And ISRO's organizations like this comes under Prime Minister's office, Department of Space, ISRO, and InSpace and NSIL, and so many other things are there. Now, startups. In India, you see the number of startups, how they have increased in the last 4 or 5 years, and is expected to go up to much beyond this, to nearly 300 by 2030. This is only until 2023. And startups have started giving phenomenal increase in the last 6 years. Nearly 350 have been already started functioning. The huge talent pool. Two startups have shown immense capability. There's a satellite startup called Skyroot. It's made its own satellite and got it launched, called Vikram. It's got satellite, got launched. And another startup called Pixel. They have made revolutionary software work in image processing, which has also caught the attention of many leading scientists. So this has brought out some talents in the startups into the space folder by which our country is benefiting. And anyway, the satellite launched by Vikram is a small satellite, and small satellite is a favor of this decade. If you know Elon Musk, he's launching 1,000 satellites to create internet through space. So he's all looking for small satellites in very low altitude orbitude, so that he can give internet connection through satellites and not through undersea cable. Till now, we have only seen the internet going through undersea cable. Now it's slowly shift to satellite. Whether it's more expensive or less expensive, we'll have to see. It is not there in India now. Of course, space is a backup, but mostly it is through undersea cable, which we have internet. So government has given about 1,000 crores as venture capital for startups, the budget, which will be used in 5 years period of time. So with this background, let us look at some numbers of space economy of India. India's space economy, 74% is from that money coming from data, which is being sold, while it spends about 22.3% on the upstream launch operation, and around 4% all for some manufacturing of some equipment which is required, right? So now what ISRO did, ISRO entered into a contract with the international firm called Nova Space in 2024, last year, and tell what has India benefited from this space missions? How much money we have spent so much of money. We have spent nearly $60 billion and by way of manufacture as well as services, we are given about to the India GDP. And in 2024 is 8.4 billion GDP. It will go up further, 47 lakh employment, and space activities have got revenue of 24 billion. But what has been the benefit given to fisheries and agriculture and crop forecasting, disaster avoidance, resource planning? So this joint report was worked out between ISRO and Nova Space, and they have said for every rupee spent by ISRO, 2.54 rupees has come back to India as benefit. The beneficiaries can be farmers, it can be fishermen, it can be government, it can be defense forces, it can be schools, it can be hospitals using telemedicine, it can be ocean exploration where they are away and they're using satellite link for transmitting all the data. So a whole lot of activities which are taking place where link is through satellite. The return is 2.54. So every rupee spent is a very important factor, very gladdening factor, that for every rupee spent on ISRO's space mission, We have got return. We don't actually see it, actually. We don't feel it sometimes. But the fact is, the Indian citizenry, rural as well as urban, your DTH, you are paid to Tatas. Tatas are paid to NSIL. NSIL is paid back to the ISR for making this. So you find that we have been able to improve the quality of living for Indian public, improve the standard of conditions in rural India, improve education, improve health, improve agriculture, etc. And the result has been 2.54 times the money we have spent. This report, which came only in end of 24, is summary is available on the net. Those of you interested in reading more can read that. And it is expected that it will grow further. We'll grow to $44 billion by 2033. And today, 40% of the world's global economy is by USA, 7% by UK, but India is only at 2%. But we want to grow to more than 8%, 9%. We want to grow. But the global space economy also is going to grow to 1.8 trillion. So it's going to be a race. What I'm saying is, space economy is a new race for countries to make sure that they are having a significant role in the economic activities, in the global economic activities. And space is going to be the medium. So, last point on this 25 years, India launched 398 foreign satellites in the last 10 years. You know this. We have launched 398 foreign satellites in the last 10 years.
സാറ് കട്ടായി പോയോ? ഒരു മിനിറ്റ് വെയിറ്റ് ചെയ്യും. യെസ്. Unmute ചെയ്യും സാർ, അൺമ്യൂട്ട് ചെയ്യും. പ്ലീസ് അൺമ്യൂട്ട്. അൺമ്യൂട്ട് ആയില്ലല്ലോ. അൺമ്യൂട്ട് ആയില്ല.
Now,
പറയും ഇപ്പൊ കേൾക്കാം.
can you hear me? Okay, how many minutes you lost my voice?
Only
up to 398 for it.
Up to, okay. So if you permit me, I'll just go back by one slide. Okay, here. The slide is here.
no, slide
sorry
is not
for
there.
this.
Slide is not here. You have to share.
Slide is not there?
No.
Okay, I'll share again. Share. The പ്രശ്നമാണല്ലോ അത്. Sabue?
Yes.
Can you hear me?
Yes.
But I'm not able to get Zoom. Am I connected?
Yes, connected. Just to share.
I'm not getting the share button.
You just minimize.
Okay. Let me expand this. Okay, I got the share now. Right. Share.
Yes, it's coming. No problem.
Coming. I'll go to full screen. Okay. I'm happy to someone who said 398. Thank you.
It's starting only.
I'm just going back by one slide. Okay, so we said we launched about 398 satellites for foreign countries the last 10 years. And the highest has been for USA. 232 satellites we have launched for USA. UK 86 and 20 for Singapore. Many of us don't normally get to read this much on the newspaper or on the TV. We don't get to see it. But that has been the extent of work which we have been doing with other countries. And it's been a great effort by SRO. So let's make some global comparisons, how we are doing. This is a very important slide. Can you see a red dotted line? Dotted line. That is equator. And I put a box around the equator, not equal on both sides, but just to contain 5 red dots. These red dots and orange dots are the satellite launch centers. And I put the one closest to equator or close to equator. Why is a satellite center preferred to be close to equator is the issue. When you launch from equator, and the moment the satellite goes vertically up, it gets maximum push from Earth's rotation. You know Earth is rotating from west to east. So if it turns towards the east, that means satellite goes up from Sriharikota and turns towards east, then it will pick up speed and save on fuel if you are near equator. If you're far away from equator, like Russia is, or some of the American satellite centers are, then your saving on fuel is not much. Therefore, they need to carry more fuel, and therefore it is heavier. All the penalties come. But India has been extremely fortunate. So is Indonesia, so is Brazil, so is Kenya. They also have. There's one dot here, just above the equator. French Guiana is most preferred satellite center in the Atlantic. Second point, one is close to equator. Second, you should always have a sea to the east. A sea front should be there to the east, so that if there's a problem with the satellite, you can ditch it to the sea and not fall on land where the population on the ground may get affected. So these are two important aspects, and India has got the geographical advantage of having Sriharikota next to Bay of Bengal. Right. Now, if you look at the number of launches, you see USA, China, Russia, India so small, only 17 launches in 3 years. Very, very small, but still we have made an impact. We are 4th there, 5th here, 6th somewhere else. So even with less number of launches, we have been able to get a higher percentage of success. First of all, geographical advantage. Second, close to equator and having sea on the east. Third, higher success rate. With less launches, we have been able to get more missions completed. Today, if you look at satellites in the world, there are 7,500 satellites in the world. 7,560 satellites. India has only 51. America has 5,100. So whether they require 5,100 or not is not the question. But we have only 51 satellites, and they are giving us most of the work. And so far, from whatever I have said, except for Navik, most of our programs have been successful, timely completion, etc. But unfortunately, Navik, we have gone through some failures. Now, if you look at the expenditure, you look at America's expenditure and India's, they spend $80 billion, America. This is 1 year. Huh? And if you look at China, it is 19.8. It's here. And India, it's 1.89. So if you look at this, there are 4 colors here. India's expenditure is almost the same in 22, 23, 24, etc. So we have been spending less than 2 billion a year for our space missions. Less than 15,000 crores we have been spending. But the returns which are coming today is 2.5 times more than what you are spending. Now comes to the last point, but very important point. So-and-so satellite retired from, so-and-so thing damaged, so-and-so thing is burned out. They're all junk in space. Today, there are more than 16,000 pieces of debris in space. This is a challenge. They're just going, rotating all the time in orbit in the space. No owner or the original owner has forgotten. It is still lying. There's no way you can get back the debris. There's no way you can shoot it down. So this debris in space is becoming a big problem. If it's a low orbit debris, what happens is a low altitude orbit, then what happens is slowly it becomes, you'll find due to aging, you find it slowly losing speed, and then it tends to fall down in altitude a little bit, and it comes in contact with some part of atmosphere, which causes drag. It slows it down. Again, it comes down. It gets into contact with the atmosphere, slows it down, drag. So it goes on. After some time, it'll burn out because of the drag from the atmosphere when it enters that. That is why re-entry of the space shuttle, this thing is a very critical issue because so much heat is produced. So I'm not talking about those things which are got burned out, but other than that, nearly 16,000 pieces. They're not full satellites. Some are half satellites. Some are broken pieces. Some are just the solar film panel, etc. Now, they are expired. They are of no use. Russia has got 7,000 odd in space. USA 5,000. China something more than 3,800. India 114. Are lying in different orbits. Some are at medium altitude, some are at high altitude. There's a picture here which shows most of the low altitude things have got burned out, as I told you, because they come in touch with some part of atmosphere and get burned out. But the medium altitude and the high altitude are still surviving. Surviving means still there. It's a hazard, but they are operating in orbit aimlessly. Now, with this, how do we take our space mission forward? I come to my last slide. India should implement its space policy, which was issued in 2023, to attract foreign direct investment and promote innovation. We have made a policy. It becomes very clear to the industry, and very clear to the government what they will do. We should consolidate ISRO's position. ISRO is today's sixth largest space agency in the world. So we should consolidate it. And our most challenging project ahead is Bharatiya Antariksha Station. That is Earth's space station. That we are wanting to do by 2035. A tall order, maybe 2040 we'll be ready. We want to become a space technology leader and contribute at least 8% of space economy. Today we are contributing only 2%. So we want to quadruple it. While the space economy itself will go to $1.8 trillion. We want to promote startups and propel them through in space using the 5-year venture capital, and a lot of emphasis to be given to startups on telemedicine, telecommerce, teleeducation. Capitalize on Sriharikota's favorable geographical position. And I'm told they are looking for one more place for a space center. Obviously, it has to be on the eastern side, very close. It has to fall to the sea, that side, and close to equator, but the location is still not announced by the government. And low-cost services, and we are able to do this low cost as well as by our ability to do innovation, which doesn't cost much. Continue to build up downstream. That is where the money is. The revenues in downstream data. So continue to build it, be it imaging services or communication facilities to be this thing, or for satellite TV. And now the demand is for small satellites, whether it's for internet. So enter into that market so that your downstream segment becomes more prominent. obviously strengthen the ecosystem to get from 2.54, try and reach 3.0 multiplication factor. Look at the low cost. We should sustain our low cost, and our long-term viability should be maintained so that there is competition abroad. SpaceX from USA is a big competition, which is run by Elon Musk. It's a huge competition for us. So we should be prepared to compete with him when it comes to small satellite programs. And of course, contribute to international efforts to do something about space debris, and also to form a space legislation which is absent today. There is no law as far as space is concerned. There's no framework. At some point it will come. It should come. So as and when the discussion starts, there is now a law for oceans. There's a law for what is to happen on land, but there's no law for what should happen in space. So that should come. And when it comes, we should contribute towards that. With this, I come to the end of my presentation, ladies and gentlemen. Sorry for this interruption at some point of time. Thank you very much for putting me back on track on that. Jai Hind. Thank you.
Thank you, sir. Thank you. Thank you very much. So you're explaining India's action plan. Particularly, India has been making significant strides in space economy with ambitious plans with ISRO and similar organizations, and particularly in expanding satellite technology and services, and Gaganyaan, that is a human space flight program, and similarly in lunar and planetary explorations, reusable launch vehicles, and private sector participation, space tourism, and space, so many areas with space-based solar power. So thank you very much, sir. Thank you once again. Then,
Are there any questions I can answer?
yes, I will call Ishan. Ishan, can you say something?
Sir, my question is, in Gaganyaan, the manned mission, which rocket will be used to send the people to space?
GSLV Mark III, which is the latest GSLV. I told you GSLV, we started with Mark I, which is a failure because our cryogenic engines did not work well. Then we modified to Mark II with some Russian rockets, etc. That is more of experimental work, and now we have made our own cryogenic engine, and that is in Mark III. We will be launching it by GSLV Mark III. But remember, GSLV stands for Geosynchronous Space Launch Vehicle. And geosynchronous means it can take you up to 36,500 kilometer altitude.
Sir, I have another question. Sir, I have another question.
One second, Ishan. I think his net connection has some problem. 1 second, he's coming back. Unmute, sir. Yes.
Yeah. Looks like it's my problem, isn't it?
It's a network problem.
My internet connectivity is not reliable, perhaps.
Yeah.
Okay.
Ishan,
anyway, got you back. I'll reply to Ishan.
Ishan has one more question. Ishan has one more question. Ishan, please.
No, let me finish the first question. So it will be GSLV Mark III. And please remember, it can go up to 36,500 kilometers, but we don't require that altitude for manned mission. Manned mission will go only up to around 400 to 500 kilometers only. By then, it will eject the crew module and the service module together as one group, and the rocket will fall off. So they will go around the Earth for 5-6 days or 7 days, and they will eject further and fall into the sea. Okay, one more.
So, in the rising population of the earth, clean water is becoming scarce. So, can we get more water from a natural satellite from the outer solar system?
I'm sorry, I have not understood the question.
Can we get more
What is the
clean water?
question, Ishan?
So what is
Can we
More clean water from
from
what is
a
is
asteroid?
more
the
clean
water-
water from space.
Yeah,
because
You are saying more clean water from space.
yes.
Yeah. So as I see it, we have been engaging ourselves only in study of how water is available on moon to start with. We have completed the study. Rover and Pragyan have completed the study and they have brought some data. We will perhaps do a similar study on Mars in addition to whatever you have done earlier. Getting water from space to Earth physically, I can't think of a method by which you can get it, as per me. But there could be some scientists in the audience, someone who knows more about this, who can say how to get water from space through what method. Physically, the water cannot be brought in sufficient quantity to Earth. You can bring a sample if you want.
Eh,
Like
Can we
many people have tried bringing samples of moon rock they have brought, soil from moon they have brought. Some water from moon can be brought as a sample, but not for extensive use in the Earth. This is as per me.
Hmm.
Nor can you
So
run a pipe from here to the moon.
in the future we may be able to?
So that technology I'm not able to visualize. It's a good idea, but I will come back to you separately if I'm able to lay my hands on some foresight of some scientists on this. But at the moment, as per me, it's no. It's not possible.
Thank you, sir.
Okay.
Apart from medical part, you can have a research on that, Ishan. Okay, Srikumar sir. Thank you. Thank you, Ishan. Srikumar sir. Unmuting.
Me? You're asking me, Abu?
Yes, yeah, Sri.
Yes.
Yeah. Actually, you have taken a very good effort to have all this statistical information. It's quite a lot of time you have taken. Very good presentation as usual. Actually, I had a nasty question in mind. Is there any chance of piracy in the like in sea, in sky? Piracy of
The,
our, uh, I mean, whatever you downstream
yeah,
you are
okay. So
sending. Huh?
let me answer this question. Let me answer this question. Satellites are launched from Earth and placed in a transfer orbit, right? Till then, it goes through some pre-prepared program, which is in the software inside the spacecraft. The booster fires and sustainer fires, and then that separates, second stage separate, third stage separate. So they're all pre-programmed, and they are finally, the satellite is left in the transfer orbit by the launch vehicle. From the transfer orbit is like a bus stop, bus stand. All the satellites come there and they're all going around there. And from there, you take your specific orbit. Okay. So this transfer orbit, from transfer orbit to your final destination, final orbit, it is controlled based on some inputs from ground. Okay. So because the satellite needs to be tracked by our ground station, and you know where exactly it has to be taken. And it is, of course, satellite has got its own inertial navigation system, but still the control is taken from ground, and the tracking system tells you where it is and then puts you onto that place. Now, if you are able to jam the ground station by some, let's say, you say this in a spy ship like China sent to Sri Lanka some months back. So a ship is there which will jam. Where is the space center control? I really don't know in India, but I think it is in Bangalore. It may be some other place also. So let's say Bangalore has got a control station from where they're able to control the satellites. If you're able to jam Bangalore station, then his communication doesn't reach the satellite.
Yeah.
Okay. Then you make sure somebody else is able to transmit to him and then take him away. Theoretically possible. Provided you know the you know the frequency, you know the codes, etc., etc.
What I mean, it may be
But
in
it's
the
possible.
upstream sector, it may be difficult, but in the downstream sector, what you are transmitting,
No,
what you are,
downstream, what does the satellite do? It is taking photographs and sending it. It is some data is coming from here, giving to Tata Sky, and then it is giving you, somebody is wanting for telemedicine. It connects to some other rural India, some other place. So there is no data worth hacking, right? The
backing up.
satellites, main thing is it is being portioned in a place, and all the money is from downstream.
Yeah,
This is reaching our population.
yes.
If you take it away by some method, then you are depriving of that service to the country from that satellite.
You mean it is of
I'll
no
give a
use
simple
for
example.
the, yeah. You mean
I'll
it
give a
is of
simple
no
example.
use for
Navik.
them? Yeah.
Yeah, I'll say give an example of Navik. You know, Navik has got only 4 satellites now. 3 more are required. Somebody manages to jam your control and disable the 6th satellite.
Yeah.
If they do that, then your Navik will never get completed. For you to do exact location of where Sri Kumar is in Trivandrum, you require 3 satellites to cover Trivandrum.
Yes.
Where exactly Ishan is in Kottayam, you require 3 satellites to cover it. So if somebody has taken away 1 satellite of yours, you will not be able to cover 3 satellites throughout India. It has been designed in such a way, in every place you will have 3 satellites looking at you. Then only the triangulation will work for getting an accurate position of yours.
Yes.
It is possible. I think that is an answer which I can give confidently.
Thank you.
Yeah. Sabu?
Yes, sir. Hari sir. Admit.
Very interesting talk. My minds go back to 1963 period, because during that time, I think it is from October 1963 onwards, I think launching was started. Every Wednesday, we used to go up to the terrace and look skywards, because that is the day on which ISRO used to launch rockets, not satellites.
Sounding rocket. Sounding rocket.
No, at that time, people are telling, we are wasting money. See, unnecessary, about 50 lakhs have gone up there like a fire. Now, there was the impression it's a wastage of money. Now, from the stock, it is proven that this is going to add to GDP in future. But let us hope we have to go a long way. hope you will succeed.
No, it is not very long way. It is not very long way for us. We have covered a lot more distance than other countries.
No, what's
Other
that?
countries who are ahead of us
But
in
still
shorter
three
time.
countries are ahead of you.
Yeah, they will continue to be ahead of us because they are technology leaders.
Correct,
But we have covered our distance pretty well.
And regarding
For,
Ishan's question about the bringing water from outer space, I am reminded of a small story of the scripture when Bhagirath, he took woe and did penance to bring down Ganga. That is the story goes. Scriptures will find. Perhaps Ishan, sometime after 400 or 500 or 500 years, some scientists will find some method to bring transfer water. And Sri's question, I think, apart from that piracy, some people can steal the data. The data is being, if you know the code message and everything, is not possible. When you transfer data from your station to, say, to control station, somebody can hack it and steal the data. Is it possible?
Yeah, but the ISRO in its design would have taken care of all this in multiple protocols by which it is safe.
Okay, thank you. It's very
Thanks,
interesting
Hari.
talk.
Thank you, Hari.
Okay.
Sabu?
Anybody else? Mohandas, sir?
Yes, sir. എന്താ പറയുക, നമ്മുടെ സ്ഥലം തിരുവനന്തപുരമാണ്. ഈ പറഞ്ഞ തുമ്പ റോക്കറ്റ് ലാൻഡിംഗ് സ്റ്റേഷനൊക്കെ വളരെ അടുത്താണ്. പലതവണ അവിടെ പോയിട്ടുണ്ട്. അവിടെ ആനിവേഴ്സറിക്കൊക്കെ അവർക്ക് പബ്ലിക്കിന് പെർമിറ്റ് ചെയ്യാറുണ്ട്. പിന്നെ കനകക്കുന്നിലൊക്കെ സ്പേസിന്റെ എക്സിബിഷനൊക്കെ കണ്ടക്ട് ചെയ്യാറുണ്ട്. അതൊക്കെ കാണാനുള്ളതുണ്ട്. ഈ പറഞ്ഞത് ഞാൻ 1958 ജനിച്ചെങ്കിലും 58 ഒക്കെ ആകുമ്പോൾ വളരെ നമ്മുടെ ചൈൽഡ്ഹുഡിലാണ് ഈ സമയത്ത് പറഞ്ഞ പോലെ റോക്കറ്റ് ലാൻഡിങ് ഇതൊക്കെ നമ്മൾ വളരെ കൗതുകത്തോടെ കണ്ടതാണ്. ഞാൻ പ്രീഡിഗ്രിക്ക് പഠിക്കുമ്പോൾ ഒരു അതിലുണ്ടായിരുന്നു സ്പേസിനെ കുറിച്ചുള്ള ഒരു ആർട്ടിക്കിൾ ഉണ്ടായിരുന്നു. അപ്പൊ അതിൽ പറഞ്ഞതാണ് ഒരു ആ റൈറ്ററിന് വളരെ ഇതായിട്ട് ഇമാജിനായിട്ട് എഴുതിയതാണ് വർഷങ്ങൾക്ക് മുമ്പേ. ഇക്വിറ്റോറിയലിന്റെ അടുത്ത് ഒരു പ്ലേസ് ഉണ്ടാവും. ഇറ്റ് ഈസ് അയാളെ ഒന്ന് വിളിച്ചിട്ട് പറഞ്ഞു താമ്പ എന്നാണ് എന്ന് പറഞ്ഞു. നെയിം കാർഡ് താമ്പ, വിച്ച് വിൽ ബിക്കം ദി സാറ്റലൈറ്റ് ലാൻഡിംഗ് ആയിട്ടുള്ള വളരെ പ്രോമിനന്റ് ആയിട്ടുള്ള പ്ലേസ് ആയിട്ട് മാറുന്നുള്ളത്. ആ ഇക്വിറ്റോറിയലിന്റെ അടുത്തുള്ള ഒരു പ്ലേസ് തന്നെയാണ് നമ്മുടെ തുമ്പ. താമ്പയും തുമ്പയും ആ സ്പെല്ലിങ്ങിന്റെ ഒരു ഇത് മാത്രമേ ഉള്ളൂ. പക്ഷെ ഇന്നത് വളരെ പ്രോമിനന്റ് ആയിട്ട് ആയിട്ടുണ്ട്. ആ ഒരു ഇൻഫർമേഷൻ ആ ഒരു റൈറ്ററുടെ ആർട്ടിക്കിളിൽ നിന്ന് ഇവരൊക്കെ സാധിച്ചിട്ടുണ്ട്. ഈ പറഞ്ഞ പോലെ ട്രിവാൻഡ്രത്തെ ISRO ഇഷ്ടം പോലെ സയന്റിസ്റ്റ് ഉണ്ട്. ഇപ്പം തമിഴ്നാട് ആന്ധ്ര, തമിഴ്നാട്ടിലുള്ള എല്ലാവരും ചേർന്നിട്ട് തന്നെ അവിടെ ഒരു ഓർഗനൈസേഷൻ തന്നെയുണ്ട്. അവർക്ക് തമിഴ് സംഘം എന്ന് പറയുന്ന പോലെ ഈ മറന്നുപോയ മാണിക് വാസൻ സാറ്, പിന്നെ ശിവൻ സാറ് എൻ്റെ വീട്ടിന് അടുത്താണ്, വളരെ നെയ്ബറാണ്, ജസ്റ്റ് ഒരു ഫർലങ്ങുള്ളൂ അവിടെയാണുള്ളത്. പിന്നെ അന്വേഷിച്ച് നാരായൺ, ഇപ്പോഴത്തെ ഉള്ള നാരായണൻ, ഇവരെല്ലാം വളരെ അസോസിയേഷൻ ഉള്ളവരാണ്. അവിടെ തന്നെ സയന്റിസ്റ്റിനൊരു ഗ്രൂപ്പ് തന്നെ ഉണ്ട് ഞങ്ങളുടെ. അവിടെ നിന്ന് ഈ കുട്ടികൾക്ക് വേണ്ടി വെക്കേഷൻ ടൈമിലൊക്കെ പ്രൊജക്ടർ യൂസ് ചെയ്ത് തന്നെയാണ് സ്കൈയും സാറ്റലൈറ്റും എല്ലാ റിസർച്ചിനും എല്ലാ കാര്യങ്ങളും കുട്ടികൾക്ക് പറഞ്ഞു കൊടുക്കാറുണ്ട്. ഇതുപോലെയുള്ള ക്വസ്റ്റ്യൻ ആൻസർ സെഷനൊക്കെ എടുത്തിട്ടുണ്ട്. ഇപ്പോഴും ഒരു സയന്റിസ്റ്റ് അവിടെ എഴുതിയൊരു ബുക്കുണ്ട്, കനവ് എന്നും നിലവ് എന്നും കനവ്. അത് 3 ഡ്രീം എന്നുള്ളതൊക്കെ മാറി എൻ്റെ ഇതിലേക്ക് വന്നിട്ടുള്ളതൊക്കെ. അപ്പോൾ വളരെ സയന്റിഫിക് ഫിക്ഷൻസ് ഒക്കെ അവിടെ വളരെ തമിഴിൽ തന്നെ ലോക്കൽ ലാംഗ്വേജിൽ അവൈലബിൾ ആണ്. കുറെ സയന്റിസ്റ്റും ഇവിടെയുള്ള ഒരു അക്വന്റൻസും എനിക്ക് ഇപ്പോഴും ഉണ്ട്. സാറിപ്പം അയ്യർ സാറെന്ന് പറഞ്ഞ പോലെ ചെറിയൊരു സ്പേസ് ക്രാഫ്റ്റിൽ നമ്മളെ കൊണ്ടുപോയി ഈ മൊത്തത്തിലും സ്പേസിൽ നിന്ന് കറക്കി വീണ്ടും നമ്മുടെ എർത്തിലേക്ക് ഉണ്ടാക്കിയതുപോലെയാണ്. ഓക്കെ സർ, ലോട്ട് ഓഫ് ഇൻഫർമേഷൻ.
Thank you. Sabu, anybody else?
Yes, sir. I think George sir is there? Nobody is there. Okay. So thank you, sir. Thank you very much once again.
Thank you very much. Thanks a lot. Ishan, I'll come back to you on the water. Okay. Bye-bye. Good night. I'm leaving.
Good night.
Good night.
Bye. Thank
Good
you,
night.
Ishan. ഓക്കെ, ഹരിഹരൻ സാർ, താങ്ക് യു. ഇപ്പൊ മൺഡേ കാണാം അല്ലേ സാർ, ഹരിഹരൻ സാർ?
കാണാം.
ഓക്കെ. ശ്രീകുമാർ സാർ, എന്നാണ്ട് വിശേഷമൊക്കെ? അൺമ്യൂട്ട് സാർ.
അല്ല പറയൂ.
എങ്ങനെയുണ്ട് ബിസിനസ്, സ്കൂള്?
ബിസിനസ് ഒക്കെ ഇങ്ങനെ ബിസിനസ് ആയിട്ടൊന്നുമില്ല.
സ്കൂള് ഞാൻ തിരിച്ചെടുക്കും.
സ്കൂൾ പരിപാടികളേ ഉള്ളൂ.
അതെ, ഞാനതാ ഉദ്ദേശിച്ചത്, പെട്ടെന്ന് അങ്ങനെ ആയിപ്പോയതാ പറഞ്ഞു.
അതേ ഉള്ളൂ നമ്മൾ ഒറ്റ ബിസിനസ് ആയിട്ടുള്ളത്.
അതല്ല, അത് നമ്മളുടെ ഒരു പാഷനാണ്, ബിസിനസ്.
പാഷനാണ്. സമയം കിട്ടാറില്ല, വേറെ ഒന്നിനും സമയം കിട്ടാറില്ല.
ഓക്കെ. പരീക്ഷ സമയമല്ല, അതിന്റെ തിരക്ക് കാണുമല്ലോ.
അതെ.
പരീക്ഷ സ്റ്റാർട്ട് ചെയ്തില്ലേ? ഇപ്പൊ കുറച്ച് സ്റ്റാർട്ട് ചെയ്തു അല്ലേ?
സോറി,
പരീക്ഷ സ്റ്റാർട്ട് ചെയ്തല്ലോ.
പരീക്ഷ മൺഡേ സ്റ്റാർട്ട് ചെയ്യാം. 11th, 12th, 10th എല്ലാം സ്റ്റാർട്ട് ചെയ്യാം.
11th, 12th, 10th എല്ലാം മൺഡേ ആണ് അല്ലേ?
അതെല്ലാം ഫ്രം മൺഡേ സ്റ്റാർട്ട്.
ചെറിയ കുട്ടികളുടെ കഴിഞ്ഞു.
ചെറിയ കുട്ടികൾ അത് ഏപ്രിൽ വരെ പോകും.
ഏപ്രിൽ. ഇതിപ്പോ 10, 11, 12 അല്ലേ? 10, 11, 12.
പിന്നെ ഒരു സ്കൂൾ എക്സാം ആണ്.
10, 11, 12 ക്ലാസ്സുകൾ സ്റ്റാർട്ട്.
10,
11, 12 സ്റ്റാർട്ട് ചെയ്യും അല്ലേ?
അതല്ല അവർ ഗവൺമെന്റ് എക്സാംസ് ആണ്.
ഓക്കെ.
Anyway, thank you.
Thank you, sir. Thank you
for the presentation. Very good presentation.
Madhav sir, namaskaram. Sir. അൺമ്യൂട്ട്. ജോർജ് സാറെ കണ്ടില്ലല്ലോ, ഇവിടെ പോയി. സാറ് കാണുന്നില്ലല്ലോ.
സാറേ ഇവിടെ ഉണ്ടായിരുന്നു.
എന്തായിരുന്നു? കൊച്ചിനെ നോക്കുവാണോ?
കൊച്ചുമക്കള് രണ്ടുപേരും ഉണ്ട്, അതുകൊണ്ട് പിന്നെ അവരുടെ കൂടെ കൂടി.
രണ്ട് മക്കളേതാ?
അങ്ങനെ ഇരിക്കുന്നു.
2 മക്കളേതാ?
മോന്റെ കൊച്ചും മോളുടെ കൊച്ചും.
രണ്ടുപേരും എത്തിയോ? മോള് വന്നിട്ടുണ്ടോ?
മോള് ഇന്നലെ വന്നു.
ഓ ശരി. രണ്ടുപേരും ഒരേ പ്രായമാണോ?
അല്ല, മോളുടെ കൊച്ചിന് 3.5 വയസ്സായി.
അപ്പൊ പുള്ളി നോക്കിക്കോളൂല്ലോ ഇളയാളെ.
അയ്യോ, നോക്കും. ഇളയവൻ മറ്റവന് വാട്ടം പിടിച്ച് അടിക്കും.